So in this video, we can see this serializable schedule. Okay. So here a non-serial schedule of n transactions is said to be serializable if there is some equivalent uh, serial transactions of the same n transactions. Okay. So here if you have given a transaction T1 and it is a non-serial, that is non-serial means that they become it is first you have a read, then write, then transaction T2 having again write again at T1 comes and then the T read, write, find the right everything. So this is a non-serial. So what is so it is this is another schedule having the again the same set of transactions T1 and T2. Okay. So in this case, the transactions here in first we can start with all the operations in T1. After ending this T1, then the T2 starts. That is a serial operation. Okay, serial schedule. So here this is T2. Okay, T2. Okay. So here, what is serializable means if there exists a non-serial schedule. So here, this is the non-serial schedule having n transactions. It is said to have a serializable if there exists an equivalent serial schedule. ഇതിന് equivalent ആയിട്ട് ഒരു serial schedule ഉണ്ടായെങ്കിൽ with the same set of n transactions, then we can say it is a serializable schedule. So our aim is to find out what are which how what whether we can means we can convert our not serial schedule to an equivalent some serial schedule. Okay. So here, when there are two schedules are given equivalent, we can see we have to check three conditions. Okay, there are three possibilities are there when two schedules are considered to be as equivalent. First one is a result equivalent, second one is a conflict equivalent, and third one is a view equivalence. Okay, so we can see the one by one. Okay, so result equivalent. So this is a result equivalent. That is here in this case, two schedule are given. And if these two schedule after execution, if they are producing the same result, then we can say it is a result equivalent schedule. So we have to, so here in this schedule S1 and this is S2. And after doing this, all the operations in S1 and S2, if they both are giving the same result, then we can say it is a result equivalent schedule. So here, and this result equivalent relation is considered to be as a least significant because most of the time the schedules may not be giving the same value after executing all the operations. The data values will be having different values. Okay, so we are not considering this type of equivalence for considering for checking the serializability. So here we can see this operations in S1 and S2. So this is reading of item X. Here X is equal to X plus 10. And we are writing the item X. You are updating the value of X by 10. And here in this schedule, the reading an item X and X is equal to X into X multiplied by 1.1 and right. So here we are sure that both are different operations, right? This is addition and this is multiplication. So both, obviously both the operations after performing the operations in S1 and S2, X will be giving a different value. So what about the value if X is taking a value 100? So here in this case, at that particular value only, we can say that S1 and S2 is a result equivalent because if X is 100, then X is equal to X plus 10. That is, X will be giving a value 110, right? Like X plus 10 or X 100, that is 110. And if here also X is 100, X into 1.1, then also it will be giving a value 110, right? So if X is taking the value 100, then S1 and S2 can be, we can say it as a result taken. But for other values, it is not satisfying the condition, and we can say that this S1 and S2 is not a result. We cannot consider for only for a single value. We have to consider all the values. Okay. So here we can say this S1 as well as S2 is not a result equivalent schedule. Okay. Okay. Next to type of equivalence is that conflict equivalence. Okay. So here in this case, two operations in a schedule is said to have conflict if they satisfy the following conditions. That is, the first one is that they have to belong to a different transactions. Okay. And they should access the same data item, and at least one of the operations should be a write operation. So that it has to satisfy these three conditions, then we can say that it is said to have a conflict. Okay, we can see an example schedule S. So here this is this number indexing of the operation read and write represents the transaction number. Okay, so this is read in transaction one and this is write in transaction two. So whether this is conflict or not. So according to our rule, these two things, these two operations should belong to different transactions. Right? Here, this is a different operation. This is T1 and this is T2, right? So the first condition is satisfied. Second, check for second condition. That is, both has to access the same data item. Here, this is X. This also is X. Second is okay. Okay, na? Then the third condition, at least one should be a right operation. So it is performing a right T2 is performing a write operation. So they can say it is a conflict. Okay. So here it is a conflict. Then what about the second operation? So here this is read 2. T2 is reading X and T1 is writing X. Okay. So here also both are in different transactions. Both are accessing the same data item. But and there is a write operation. So then also it is a conflict, but the order of transaction is different, right? Uh, that is here, T1 is taking a read operation. Here, T2 is taking the read operation. That doesn't matter, but there is a conflict. We need to check whether there is a conflict or not. Okay. Next conflict is that here T1 is taking a write operation and T2 is taking a write operation over that item X, right? So both are different transactions. They are accessing the same data item and they are both are write operations. So here now in a condition, at least one operation should be a write operation, right? So here both are write operations. Then obviously it is satisfying the all the conditions. Therefore, this can also be set as a conflict operation. Now we can see the next three cases which are not conflicting. So here this is a reading transaction T1 is reading X, and here this is transaction T2 is reading X. So it is first case they belong to both different transactions. There's T1 and this is T2 accessing the same item. But what about the third condition? One of them should be a right. Here both are reading. So we can say it is not a conflicting operation. So it is not a conflicting operation. So what about this thing? Here, this is accessing a data item X as well as this is accessing a data item Y. So both are accessing a different data items. It is violating the rule number 2. And here, what about this one? Here, both are having a using the same transactions, right? This is also T1. This is also T1. So it is violating the rule number 1. Therefore, it is also not a conflict. Okay. So we can after finding out the conflicts, there are two different types of conflict. The first one is a here we can see if either of the one is read and the next one is a write operation, then we can say it is a read write conflict. The first one is it is a read and this one is a write. So one of the transaction is a write operation, then we can say it is a read write conflict. The second one is also the same thing, that is a read write conflict. What about the third one? Third one is both are doing the write operations, right? Then it is called as a write conflict. Okay. So I have specified the reason why it is not conflict in the other three cases. Okay. Next one, we can see what are the different. So once again, I am repeating the types of conflict. That is first one is a read-write conflict. So read-write conflict means in here this is T1 and this is T2. So here this is T1 is reading X and T2 is reading X. So there exists a conflict, read-write conflict. Okay. Here also these are whether this is a conflict. This is not a conflict because both are having a same transaction, right? This is W2 as well as this is also W2. Okay. So here this is not a conflict. This is only the this is the only conflict here, that is a read-write conflict. So what about the write-write conflict? So here write-write conflict, both should be in a different transactions and both should access the same data item. So here this is W1 of X and W2 of X. So there exists a write-write conflict. So here this is a write-write conflict. What about this case? Here also this is W2 of X and this is W1 of X. Different transactions, same data item, and at least one is a write operation. So here this is also a write conflict. So next one type of transaction operation is read non-conflict. That is, both the transaction is having the read operations. Then if both the transaction is having the read operation, then it is not a conflict operation. Okay. Both the transaction reads. Next one is a equivalent conflict equivalence. So here, if what is conflict equivalence? So if you are given two schedules that should satisfy the following two conditions, then we can say it is a conflict equivalent schedules. What are the conditions? Let's see. So here, the set of transaction that should be presenting schedule should be the same. If you are given two set of transactions, that is S1 and S2, the transaction, the operations that is performed in this transaction should be the same as that of the S2. Okay. Suppose ഇപ്പം ഇതിനകത്ത് റീഡ് എയും റീഡ് ബിയും ആണെങ്കിൽ ഇതിനകത്ത് റീഡ് എക്സും റീഡ് വൈയും പറ്റും. Okay, it should access the it should do the same set of operations. Okay. Set of second, what is the second condition? That is the order of pair of conflicting operations of the both the schedule is same. That suppose if you are given a S1 lesson, so we can see an example. So this is the schedule 1 having two transactions. This is schedule 2 having these two transactions. So the order of the conflict, if you are having a conflict that is a read-write conflict or write-write conflict, the same conflict should be happening in the second schedule also. And the order of the if you are having a read-write conflict, then there should be a read-write conflict here also. If you are having a write-read conflict, then here also it should be having the order of the transaction should also be the same. That is what he has. The order of pairs of conflicting operations of both the schedule should be the same. Okay. So what is the case of these two schedules? So here this is not a conflicting because both are different object. Here this is reading A, this is reading B. Okay. What is the case of this thing? When considering this thing and this thing, here also that is not a conflict. But this is not also not a conflict, right? Because this is writing A and this is writing B. So that it is not a conflicting operation. There is no conflicting operations in S1. And then in S2 also, there should not be any conflicting operation. Okay. So here also, this is reading B and this is reading A. No conflict. Reader. This is reading A, but this is writing B. Then also there is no conflict. This is writing B and this is writing A. Then also no conflict. Okay. So here there is no conflict operations in both S1 and S2. രണ്ടിടത്തും conflict operations ഒന്നുമില്ല. Okay. Then we can say it is a conflict equivalence. Conflict ഉണ്ടെങ്കിൽ അത് രണ്ടിടത്തും സെയിം ആയിരിക്കണം. ആ ഓർഡറും സെയിം ആയിരിക്കണം, ട്രാൻസാക്ഷൻസും സെയിം ആയിരിക്കണം. അങ്ങനെയെങ്കിൽ അത് conflict equivalent. In this case, there is no conflicting operations. അപ്പൊ രണ്ടും സെയിം തന്നെയാണ്. Conflict equivalence ആണ്. So we can check these two schedules whether they are conflict equivalent or not. Okay. So here this is the case. So here this is T1 and this is T2 and S1 ആണ്. S2 ന്റെ T1 and T2. അപ്പൊ നമുക്ക് നോക്കാം whether there is any conflicting operations or not. Okay. So here this is here we can see here there is a conflicting, right? With a write of A and with a read of A or not. So there existing a conflicting operations. Okay. അപ്പൊ അവിടെ വന്നിരിക്കുന്ന കോൺഫ്ലിക്റ്റ് എന്ന് പറയുന്നത് ഫസ്റ്റ് റൈറ്റും പിന്നെ റീഡും ആണ് കേട്ടോ. സോ സെയിം തിങ് തന്നെ ഇവിടെയും വരണം. ദ ഓർഡർ ഓഫ് ദ പെയർ സെയിം ആയിരിക്കണം. അപ്പൊ ഇവിടെ നോക്കിയേ, read of A, write of A is there, as well as read of A is there. So here there is same, അല്ലെ? Here also, right of A, read of A. Same parallel, same order, that is a read write conflict. So here this is there is a conflict, that is a read write conflict. ഇനി വേറെ ഏതെങ്കിലും conflict ഉണ്ടോ എന്ന് നോക്കിയാൽ, that is here right of A, this is read of B, right of B ഇതും check ചെയ്യാം കേട്ടോ. So if there is രണ്ട് റൈറ്റ് എടുക്കുക, നമ്മുടെ ട്രാൻസാക്ഷൻ റീഡ് ആണെങ്കിൽ just we can skip that read and check for the other rules. Okay, so that is we can call this as a blind read. Okay, so right ഉണ്ടെങ്കിൽ നെക്സ്റ്റ് അടുത്ത ഓപ്പോസിറ്റ് ട്രാൻസാക്ഷൻ്റെ read ആണെങ്കിൽ we can skip that and check the other next transaction whether it is right. Then also it is if suppose ഇതിൻ്റെ അകത്ത് ബിക്ക് പകരം ഇവിടെ റൈറ്റ് ബിക്ക് പകരം എ ആയിരുന്നു എന്ന് വിചാരിക്കാം. അങ്ങനെയെങ്കിൽ there exists a conflict. ഇവിടെ റൈറ്റ് എ ഉണ്ട്, ഇവിടെ റീഡ് ബി ആണെങ്കിൽ ഇവിടെ റൈറ്റ് എ അല്ലേ. സോ രണ്ട് ഡിഫറെന്റ് ട്രാൻസാക്ഷൻ ആണ്, സെയിം ഒബ്ജക്റ്റ് ആണ്, രണ്ട് ഡിഫറെന്റ് റൈറ്റ് ആണ്. സോ there exists a റൈറ്റ് കോൺഫ്ലിക്റ്റ്. ബട്ട് ദിസ് കേസിൻ്റെ അകത്ത് എ അല്ല ബി ആണ്, അതുകൊണ്ട് അത് കോൺഫ്ലിക്റ്റ് അല്ല. ഇനി എ ആയിരുന്നു എങ്കിൽ then there exists a conflict. Okay, ഇവിടെ അങ്ങനെ ഇത് എ ആയിരുന്നെങ്കിൽ അപ്പൊ ഇവിടെ എന്ത് വരും, ഇവിടെ റൈറ്റ് ആൻഡ് കോൺഫ്ലിക്റ്റ് വരും, റൈറ്റ് ഓഫ് എ ആൻഡ് റൈറ്റ് ഓഫ് ബി. സോ ഇത് രണ്ടും സെയിം ട്രാൻസാക്ഷൻസ് മീൻസ് സെയിം ഓർഡറിലാണ്, റൈറ്റും ഇവിടെയും റൈറ്റ് ഓഫ് എ സെയിം എന്താണ് വന്നിരിക്കുന്നത്, ഓർഡറും സെയിം ആണ്. സോ ഇവിടെ റൈറ്റ് കോൺഫ്ലിക്റ്റും രണ്ടിടത്തും ഉണ്ട് എങ്കിൽ ദെൻ അവിടെ ഈ രണ്ട് S1 as S2 is called as a conflict equivalent. But here ഇവിടെ ആദ്യത്തെ രണ്ടെണ്ണം മാത്രമേ ഉള്ളൂ, റീഡ് റൈറ്റ് കോൺഫ്ലിക്റ്റ് മാത്രമേ ഉള്ളൂ. Therefore we can say it is a conflict equivalent. Okay. So next we can check with another example, check whether these two schedules are conflict equivalent or not. So for that, this is the given schedule S1 and S2. Try whether you can do it by yourself. So pause the video and then try it out. Okay. So now we can see the solution. So we can check for whether for the conflict operations. So here there is no conflict. So here when we consider this thing, that is also not a conflict. So here this one. So here there is a read of a write of B and there is a read of B. So there is a conflict, right? So write operation, right? So here this is a conflict. Now there's no more conflict in S1. Check for S2 whether it is having the same conflict. So there is no conflict here. A write of B and read of B. Again, skip this read and check whether there is the write operation. So here again it is a write of B, right? So there is a conflict. So this is a read-write conflict. But see, even though it is a read-write conflict, see the set of operations, the order of the operations. Here in this schedule, it is first performing the write operation, then followed by read-write. But here it is first it is doing the read operation, then it is doing the write operation. So these are both, even though both are read-write conflict, there is the relative order of these two conflicting operations. It is in S1 and S2, the operations order is not the same. Okay, so we can say that it is, since the order is not the same, it is not a conflict equivalent schedule. It is S1 and S2 are not a conflict equivalent schedule. So next topic is that what does till now we were saying the conflict equivalent. Okay, so next we can see what is conflict serializable schedule. So in conflict serializable, if it is if a non-serial schedule is conflict equivalent. Okay, first we have to check for conflict equivalent itself. If there exists a non-serial schedule which is a conflict equivalent, and if it is equivalent to some serial schedule. Okay, there should be existing if there exists in some serial schedule, and that's and if we have found that there is a conflict equivalent schedule, which is a non-serial, then we can say it is a conflict serializable schedule. So this is a very important repeated item. So we can question check whether the schedule. So first, we need to check for conflict equivalent itself, right? Then we have to find out the whether it is conflict serializable, whether that is we have to find out the serial schedule also after finding the it is equivalent, conflict equivalent. Okay, so here, so you are given, we can consider an example. So here, see, this is a serial, sorry, non-serial schedule. Okay, S1 is a non-serial schedule. Non-serial means interleaved ആയിട്ടുള്ള operations ആണ് transaction T1 T2 നടക്കുക interleaved ആയിട്ട്. And what is a serial schedule? So here you are given a serial schedule is to, okay, so here T1 full complete ചെയ്ത് കഴിഞ്ഞിട്ടാണ് T2 നടക്കുക. So after completing all the transactions in T1, T2 will be starting. Okay. Now we can see the conflict. Okay, in this, whether there is a conflict equivalent, whether these two transactions are conflict equivalent or not. So first we can check this S1. So this is read A. Okay. Read A, if this is read A, then skip ചെയ്യാം. അടുത്തത് right ആണോ? Right B. Yes, it is. So it is a read write conflict. Okay. So അതേ equivalent ആണെങ്കിൽ there should be having the same operation, അല്ലെ? സെയിം ആ ഓർഡറിൽ തന്നെയുള്ള ഓപ്പറേഷൻസ് രണ്ടാമത്തെ ഷെഡ്യൂളിൽ ഉണ്ടായിരിക്കും. സോ ദാറ്റ് ഇസ് റീഡ് റൈറ്റ്. സോ ഇവിടെ ഒരു റീഡ് റൈറ്റ് ഉണ്ടാവും. റീഡ് ഓഫ് എ ആൻഡ് റൈറ്റ് ഓഫ് എ. സോ ഇവിടെ ബ്ലൈൻഡ് റീഡ് ആയിട്ട് കൺസിഡർ ചെയ്യുവാണെങ്കിൽ ദിസ് ഇസ് എ കോൺഫ്ലിക്ട്. സോ ദിസ് ഇസ് റീഡ് ഓഫ് എ ആൻഡ് റൈറ്റ് ഓഫ് എ. യെസ് ഇറ്റ് ഇസ്. So okay, in next whether check for and whether there exists any other conflict also. So here, if this is the case, right of A and this is right of A, that is also a conflict, right? And the conflict, that is, it is a right conflict. So the same right conflict is also here. This is here. This is right of A and this is right of A. The same conflict is coming in S2 also. Then is there any other conflict here? Here, this is right of A and there is a read of A, right? So there also a right read, that is a read write. Okay. So S2 ലും അതുപോലെ ഉണ്ടോ നോക്കുക. That is first write, then read. Here there is right of A and read of A. So okay, then the same transactions, ഇത് ഇവിടെ ഉള്ള എല്ലാ ട്രാൻസാക്ഷൻസിന്റെയും കോൺഫ്ലിക്റ്റ് ഇവിടെയും സെയിം ഓർഡർ തന്നെ ഉണ്ട്. ഇനി ഇതുപോലെ ഇതിപ്പം എ എന്ന് പറയുന്ന ഓബ്ജക്റ്റിലാണ് നോക്കിയത്, അതുപോലെ ബി എന്ന് പറയുന്ന ഓബ്ജക്റ്റിൽ നോക്കുക. That is again the same. It is a write of B and a read of B, the transaction. So this is a read write conflict. So here the same is happening here also. That is a write of B and a read of B here, right? So write of B and a read of B. The second is a read of B and a write of B. So if we are considering this as a blind read of B and read write. So here, so you name read B and write B. So here, write B. So see, what does this, how we can conclude this? That is, non-serial schedule S1 എന്ന് പറയുന്ന non-serial schedule ഉള്ള അതേ കോൺഫ്ലിക്ട്സ് തന്നെ സീരിയൽ ഷെഡ്യൂളിലും ഉണ്ടായിട്ടുണ്ട്. അതേ സെയിം ഓർഡർ. The order of the operations is also same. So we can say this is equivalent, conflict equivalent ആണ് പറയാം, അല്ലെ? So അങ്ങനെ conflict equivalent ആയിട്ടുള്ള second schedule, if it is a serial schedule, then we can call it as a conflict serializable schedule. Okay. So if there exists a non-serial schedule is conflict equivalent to some serial schedule, ഇതൊരു സീരിയൽ ഷെഡ്യൂൾ ആണ്. ഇത്ര നേരം നമ്മൾ സീരിയൽ അല്ലായിരുന്നു. അങ്ങനെ ഈ സെറ്റ് ഓഫ് കോൺഫ്ലിക്ട്സ് സെയിം രണ്ട് നോൺ സീരിയൽ ഷെഡ്യൂൾ ആണെങ്കിൽ then we can say it is only a conflict equivalent. Okay, then if suppose if one of the schedule is a serial schedule, then we can call it as a conflict serializable schedules. I hope it is clear. ഇവിടെ വേറെ ഒരു right of B and right of B is coming here. Again here right of A and sorry right of B ഇതവിടെ right of B and right of B is coming here. Okay, so here we can conclude that is S1 and S2. This non-serial schedule and the serial schedule S1 and S2 are conflict equivalent, and S1 is conflict serializable schedule also. Okay, So here S1 is serializable. Okay, this is a non-serial schedule ആണ്. അതിനെ നമുക്ക് ഒരു serial schedule ആയിട്ട് നമുക്ക് convert ചെയ്യാൻ possible ആണ്. So here this S1 is a is called a serializable schedule. Okay. We can say that S1 is a serializable schedule. So conflict equivalence അത് നമ്മളിപ്പം ഡിസ്കസ് ചെയ്തതാണ് conflict serializable. That is conflict serializable concurrency means if you are accessing different ആയിട്ടുള്ള transactions ഒരേ സമയത്ത് എന്താണ് concurrency. Concurrency serializable, also known as a conflict serializability, is a type of concurrency control that guarantees the outcome of the concurrent transaction will be the same as that of the transactions that are executed consecutively. That is non-serial ആയിട്ടുള്ള transactions ഏറ്റവും എൻഡിൽ വരുന്ന റിസൾട്ടും സീരിയൽ ട്രാൻസാക്ഷൻസിന്റെ ചെയ്ത് കഴിയുമ്പോൾ അതിനുള്ള റിസൾട്ടും means our transactions എല്ലാം conflict same ആണെങ്കിൽ then we can say it as a conflict serializable. Okay, a schedule is called a conflict serializable. This is a definition. This is very important. If it can be transformed into a serial schedule by swapping some of the non-conflicting operations. So if you are able to swap some of the non-conflicting operations, അങ്ങനെ conflict അല്ലാത്ത operations swap ചെയ്ത് കഴിഞ്ഞ് if serial schedule ഉണ്ടാക്കാൻ പറ്റുമെങ്കിൽ then it is called as a conflict serializable schedule. Okay. So how we can check whether a conflict serializable, so given schedule is conflict serializable or not? So this is ചോദിക്കുന്ന ഒരു question ആണ്. So here this can be done with the help of a precedence graph. Okay, precedence graph. So if we need to construct a graph from the given schedule, and if this graph is free from cycles, okay, so I hope you are familiar with the cycle and a cyclic graph and all. Okay, so then if it is free, if there is no cycle in that particular graph, then we can say that schedule is a conflict serializable schedule. Okay, so we can see how you can construct a precedence graph. So here these are the rules for constructing a precedence graph. So if this you are given a graph G having vertices V and E, vertices mean the set of vertices and E is the set of edges. The set of vertices is containing, this vertices means all the transactions T1 and T2, all the transactions will be the vertices. And what will be the edge? The set of edge will be, that is, if you have an edge from Ti to Tj, then they should have one of the three conditions should hold. That is, we can create an edge from T1 to Ti to Tj if Ti executes a write operation before a Tj executes a read operation. That is, if there exists a read-write conflict. Okay, but a write-read conflict ഉണ്ടെങ്കിൽ then Ti നിന്ന് Tj ലോട്ടൊരു edge നമുക്ക് possible ആണ്. The second case is that executes Ti executes a read. First read Ti എന്ന് പറയുന്നത് T1 ആണെങ്കിൽ, suppose the second case, suppose T1 is this thing and this is T2 is another vertex. Okay, so if there is a edge from T1 and T2, ഇവിടെ ഒരു directed graph ആണ് precedence graph. Okay, so if there is an edge from T1 and T2, oh sorry, if there is a edge from T1 and T2, that is T1 transaction that the first read operation and if they execute a read operation before executing a write operation, that is a read write again, it is same type ആണ് queue. അപ്പം write read operation ആണെങ്കിലാണ് നമുക്കൊരു edge ഉണ്ടാവും. Again, the third case, the conflicts ആണ് ഈ പറഞ്ഞിരിക്കുന്നത് കേട്ടോ. ഇത് write read, ഇത് read write. Again, this is one as a write write. So Ti executes a write of Q before Tj executes a write of same that item Q. Okay, so this is Q എന്ന് പറയുന്നതാണ്, that is T1 ഉം Ti and Tj. Okay, ഏതെങ്കിലും ഒരു കണ്ടീഷൻ ഉണ്ടെങ്കിൽ then we can say it is having a miss edge. So if the precedence graph contains only a single edge, that is Ti from Ti to Tj, then all the instructions of Ti are executed before the first instruction of TJ is executed. So if there is only a single line, that means it is first TI transactions should be executed first, after followed by TJ. If the precedence graph of the schedule S is having a cycle, precedence graph ഇതുപോലെ cycle, അപ്പോൾ suppose നമ്മൾ വരച്ച് കഴിയുമ്പം from T1 to T1 to T2 and from T2 to T1 if there exist edge, then it has formed a cycle. Then we can say this transaction, this set of S is a schedule, right? S is non-serializable. Okay, and if it is not having any cycle, then it is serializable. So here this is having a cycle, so this is non-serializable. Here this is not having any cycle, so this is called as a serializable. So check whether our transaction S1 is conflict serializable or not. You are given a transaction S1. These are a set of transactions, T1 and T2, and T1, you are given some operations, and T2, you are here also there are some operations. In the non-serial schedule. Then we have to find the conflict. Okay, conflict serializable or schedule first number conflict. Okay, first conflict we can check for whether there exists a conflict or not. So here there is a read of A. Even read of A and next operation write of A. So there exists a conflict, right? So if you are avoiding this read operation, then there is a read write conflict for the object A. Okay. Next, this is right of A as well as this is also right of A. Then also it is a conflict. Okay. So this is right of A and right of A. Right conflict. Any right read of B. Next one is read of B. That is a right of B. So then also it is a right. So read right conflict. Then again there exists a right of B and this is right of B. So there is a right conflict. So then first transaction in the first if there exists a edge, how we can so there should be a two vertices, that is T1 and T2, and how you can draw the edges. So if there exists a conflict, if R read of A to right of B. First transaction ഏതാണ്? So this is T1 അല്ലേ? So we have to draw a arrow mark from T1 to T2. Okay. So ഈ ഒരു arrow mark point ചെയ്തിരിക്കുന്ന പോലെ തന്നെയാണ്. So the edge should point towards T2 because the first operation is T1 and T2 is the second operation. So the arrow mark should be pointed towards the second operation. Okay. So ഇവിടെ അപ്പം നമുക്ക് T1 and T2 അകത്ത് അങ്ങോട്ടൊരു arrow mark വരയ്ക്കാം. So for the ഇവിടെ next one also ഇവിടെ നോക്കിയാൽ right of A and right of B. Here also T1 is the first operation, right? Right is performing, first is it is performing in T1. So again from T1 to T2. For രണ്ടടിച്ച് വരയ്ക്കണമെന്നില്ല. If you are drawing a single line, that is okay. So consider the next conflict. So here also first T1, then towards. All the pointers are pointing towards T2, right? So we can conclude that you will be having two vertices T1 and T2, and you should have a directed edge from T1 to T2. The arrow should be pointing towards T2. And these are the, it is not necessary to mark the objects. So I have marked here, that is, we have drawn the edges because the operations is done for A and B. Okay. So in this graph, whether there is a cycle or not. So here in this, there is no cycle, right? So this is the precedence graph. This is how you can draw a precedence graph from the given schedule S1. So there is no cycle in the precedence graph. So we can say it is this schedule S1 is a conflict serializable. That is, we can create a serial schedule from S1. Okay. Again, we can, next is another example, check for conflict serializable. So here your read of A and this is right of A. So there is a conflict. This is the read of B and right of B. So again, there is a conflict. So whether this is a conflict, no, right? This is read of B and this is read of A. So this is, so we have two conflict. So what is the case? So here the arrow mark is pointing towards T2, whereas in this the arrow mark is pointing towards T1. So then there exists a cycle. So from T1 to T2 for A, and for B, T2 to T1. So this is for, this arrow mark is for B. Okay. So here there is a cycle that we can say it is a conflict. Next one is if another example, we have three transactions, T1, T2, and T3. Let's check whether it is conflict serializable. So first we have to find the conflicts. What are the different conflicts? This is not a conflict. Here there is a conflict, right? Right of B and the read of B. So there is a read write conflict. Again, this is not a conflict. Good operations in the next, this one and this one. Here there is a conflict. This is read of A and this is write of A. So there is a conflict. Read write conflict. Next one, this is write of A and this is read of A. So again that is a conflict. So now we can mark the precedence with that. So there should be three vertices, T1, T2, and T3. So one arrow mark should be pointing from T2 to T3. Second one from T2 to T1, and third one from T1 to T3. So this is how your precedence graph will be looking. Okay, from T1, this one, from T2 to T3. So this is the T2 to T3. So this is from T2 to T1, T2 to T1, and this is T1 to T3, T1 to T3. So whether there is a cycle. So there is no cycle, right? So there is no cycle. If there is a edge from T3 to T2, then there is a cycle. So here in this case, it is not a cycle. There is no cycle in the precedence graph. Therefore, we can say it is a conflict serializable. So this one, the given schedule is conflict serializable. Now we have to find the order of the serializing order. So how? So we have found that this is conflict serializable, right? So that is there. We can find a serial schedule for this type of schedule S1. So how you can find the serial schedule? That is, serial schedule can be done. First, we have to remove the edge with the least. Actually, this is serializing order is found out by using a sorting called topological sorting. So, which is a sorting done in a graph data structure. So that type of sorting you will be learning in next semester. So in S6, I think, sign analysis of algorithm. Okay, so now just only I am telling the rule for finding this thing. So here in this case, what is the case? What is the least in degree and ഒന്നല്ല arrow mark towards ഇല്ല towards pointing ഏറ്റവും കുറവുള്ളത്. So here what am I getting? T2, right? T2, all the arrow mark is from the T2. There is no edges towards T2. In degree കുറവാണ്. ഏറ്റവും remove the vertex with the least in degree. Okay. So here, this is the case, that is T2 is remote, first remote. So T2 ആയിരിക്കും first നമ്മുടെ serialization orderൽ വരേണ്ട first node, serializable order, T2. So here, next after removal of T2, then T1 and T3 ആയിരിക്കും. T1 and T3. Obviously, these two edges will also get removed. So what is now what is the least in degree? Here T1 is the least in degree. So after T2, T1 comes, then finally we have the T3. Okay. So serializing order is first T2, then T1, then T3. Okay. So after performing all the transactions of T2, then you have to do all the transactions of T1, then you have to do the T3. So that should be the order for serial schedule. Okay. Next one is a view equivalence. So this is the third type of equivalence. The first one is a result equivalence, second one is a conflict equivalence, and third one is the view equivalence. Okay. So when the two schedules, that is S1 and S2, are said to be view equivalent. Okay. If for each data item, then if the initial read in this schedule S1 is done by TI, then the same transaction should be done in S2 also. So if you are given two transactions, two set of schedules, so first read operation la read, first initially read in S1 T1 ആണ് നടത്തുന്നില്ല അതേ transaction S2 ഉണ്ടായിരിക്കും. ഇനി if the final write in S1 is done by TI, ഈ transaction ആണ് final write ചെയ്യുന്നത്, S2 ലും അതേ transaction TI തന്നെ ആയിരിക്കണം final write കൊടുക്കുന്നത്. ഇനി മൂന്നാമത്തെ കേസ് എന്ന് പറയുന്നത്, if TI reads an item that is written by TJ in S1, then in S2 also, second schedule, അതുപോലെ തന്നെ TI should read an item that is written by TJ. Okay, so then we can say it is a view equivalence. So here view serializable schedule means, so next one is a view serializable. View equivalence കണ്ടുപിടിച്ച് കഴിഞ്ഞിട്ട്, if there exists a non-serial schedule, which is a view serializable schedule, if a view equivalent is to some of the serial schedule. So view equivalence കണ്ടുപിടിച്ച് കഴിഞ്ഞിട്ട്, then there exists some serial schedule which is equivalent to this equivalent ആണ് കണ്ടുപിടിച്ച് കഴിയുമ്പോൾ, then we can say that particular schedule is view serializable schedule. So next we can see whether view serializable or not. Check whether the given transaction S1 ആണ് view serializable ആണെന്ന് check ചെയ്യേണ്ടത്. Okay, so view serializable ആണെങ്കിൽ view equivalence ആണ് നമുക്ക് നോക്കേണ്ടത്. So here this is the given transaction S1 and this is S2. Okay, so first what should be the first thing? That is, first to find out the read operation. Like here in this case, the read operation is done by T1. Okay, initial read in S1 is done by T1. Therefore, the same transaction should be done in S2 also. ഇവിടെ read നടത്തിയത് T1 ആണ്. അപ്പൊ T1 തന്നെ ആയിരിക്കണം ഇവിടെയും read ആക്കുക. Okay, so initial read in S1 is done by T1. Therefore, the same transaction should be done in S2 also. So here, in this case, ഇവിടെ രണ്ടിടത്തും read T1 തന്നെയാണ് ചെയ്യുന്നത്. Second condition എന്താണ്? Final write. രണ്ട് ഷെഡ്യൂളിലും റൈറ്റ് ചെയ്യേണ്ടത് ഒരേ ട്രാൻസാക്ഷൻസ് തന്നെയായിരിക്കും. So here in S1, write B ആണ് ചെയ്യുന്നത്. S2 also is writing B. T2 ആണ് ചെയ്യുന്നത്. രണ്ടുപേരും രണ്ട് ഷെഡ്യൂളിനകത്തും ട്രാൻസാക്ഷൻ T2 ആണ് റൈറ്റ് ഓപ്പറേഷൻസ് ചെയ്യുന്നത്. So here the final write in S1 as well as S2 is done by the transaction T2. Okay, second condition satisfied ആയി. ഇനി നമുക്ക് മൂന്നാമത്തെ ട്രാൻസാക്ഷൻ whether we have to check whether the read write conflict സെയിം സീക്വൻസിൽ തന്നെയാണോ S1ലും S2ലും നോക്കുക. So read write conflict in data item is having the same sequence in both S1 and S2. So what now we have to find out the conflict. So what is a conflict? Read A, write A, right? So ഇവിടെ ഒരു കോൺഫ്ലിക്റ്റ് ഉണ്ട്, ഇവിടെ ഒരു കോൺഫ്ലിക്റ്റ് ഉണ്ട്. So first read of A and write of A. So here read of A and write of A. Okay, അത് രണ്ടും സെയിം ആണ്. പിന്നെ write of A and this is read of A. അപ്പോൾ write of Aയും read of Aയും ആ ഓർഡറിൽ തന്നെ വന്നിട്ടുണ്ട്. Okay, first one, this is the same. Then write of B and write of B. ഇവിടെ write of B and write of B. Then write of B and read of B. Write of B and read of B. Same transactions, right? So here ഇവിടെ നമുക്ക് റൈറ്റ്, അപ്പം എല്ലാ ട്രാൻസാക്ഷൻസും റീഡ് റൈറ്റ് കോൺഫ്ലിക്ട്സ്. അപ്പോൾ why we are not checking write write? So ഇവിടെ റീഡ് റൈറ്റ് കോൺഫ്ലിക്റ്റ് ഇൻ ദാറ്റ് ഐറ്റം ഷുഡ് ബി ദ സെയിം സീക്വൻസേ ഉള്ളൂ. അപ്പം റൈറ്റ് റൈറ്റ് രണ്ടും റൈറ്റില്ല, അപ്പൊ സെയിം പറയാൻ പറ്റില്ല. അപ്പൊ അതുകൊണ്ടാണ് റൈറ്റ് റൈറ്റ് കോൺഫ്ലിക്റ്റ് നമ്മൾക്ക് നോക്കാത്തത്. So read write conflict in that item should be the same sequence in both S1 and S2. So in this case, എന്താണ് എല്ലാം correct ആണ്. അപ്പൊ അതുകൊണ്ട് we can say this S1 is view serializable. So what are the important points? So every conflict serializable schedule is use serializable, but it is not vice versa. So every use serializable, conflict serializable, along it is not true. Every conflict serializable schedule is serializable, but the vice versa means serializable schedule conflict schedule. And every view serializable is serializable and vice versa is also true. Serializable ആണെങ്കിൽ view serializable ആയിരിക്കും.
So here we can discuss some more problems related to conflict is serializable or not. You are given two schedules, R1. So schedule 1 is R1 of X, and this is the schedule 1, and this is schedule 2. Okay. So we can create the table as a table form. So conflict serializable is checked with the help of a precedence graph. If this graph contains a cycle, then we can say that it is a cycle, then it is not a conflict serializable. So we can create the transactions operations for the S1. So this is how the schedule will be looking like that. Now we need to find the conflict. Okay. So conflict is read of y, and this is right of y. Again, the next conflict is right of y, right of y. So these are the conflict is S1. And next we can see the schedule is. So here this is the, so once we have created the precedence graph of S1, so here this one R1 W1. So from T1 to T2 there will be a directed arrow mark. Then from T2 to T1. Since this is the first operation executed in this conflict, so the arrow mark will be from T2 to T1. So therefore, we can, as we can see, that there is a cycle, right? So when a cycle is formed, then it is not conflict serializable. So next we can see the second schedule. So is there any conflict? Whether we can see any conflict here? Uh, yeah, read of y and uh, read. So let's see the conflict of these two transactions. So there is a conflict between these two uh, and conflict from T1 to T2, R of y and W of y. So what will be the precedence graph here? And here also we can see that there is a cycle is formed. Therefore, we can conclude that S1 and S2 are not conflict serializable. Okay. So check whether the given schedule are conflict serializable or not. So this is a question from June 2022 K2 syllabus. So here this is S1 schedule and this is S2 schedule. So here S1 it is having 3 transactions and S2 is having two transactions. Now we can see the conflict in what are the different conflicts in S1. Okay, so here there is a conflict in read of y and W of y, read write conflict. Next one from T3 to T2 there is a conflict, read write conflict. Then next we have a conflict from T2 to T1, that is read of x and W of x. So there are 3 conflicts are there. So what will be the precedence? How the precedence graph will be looking? Okay, that is from T2 to T1 there should be a arrow mark. From T1 to T2 there should be a arrow mark, and T3 to T2, right? T3 to T2. Okay. So this is how the graph precedence graph will be looking. So here, since there is a cycle is formed, therefore we can say it is not conflict serializable. So next we can see the schedule S2. Here there is a conflict, read write conflict. Then is there any other conflicts? No, right? So there is only a single conflict. Okay. So here we can say that it is here from T2 to T1. There is only a single conflict. Therefore, S1 is not conflict serializable, whereas S2 is conflict serializable because there is no cycle in this precedence graph. Next, we can see another example. So here we have to write the serialization order of the below transactions. You are given three transactions, T1, T2, and T3. First, we need to find out the conflicts. So this is the conflict from read X to write X, T1 to T3. Then read Y to write Y, T3 to T2. Then write X to write X, T1 to T2. Okay. So we have to create the precedence graph. That is, this the precedence graph will be looking like this. Okay. Is there any cycle? There is no cycle, right? So here it is a there is no it is a complex serializable schedule because there is no cycle. Okay. So now we need to find the serializing order, how it can be serialized. So here we need to find the node which is having the lowest in degree. So in degree, this is the so here this is T1, right? Remove the node from the graph which is having the least in degree. So first we have to remove T1. So first transaction in serialization order will be T1. So here in T1 should be the first set of transaction that has to be executed. So after removing T1, your graph will be looking like this. Then next we can remove the, again we have to remove the next node which is having the least integrity. So here that is T3. So in next, after T1, we have to execute the transaction T3. Then finally we have to import the transaction T2. So this will be the order T1, T3, and T2. So next we have another question, which is a question of February 2024. So you are given two set of transactions and you need to find whether it is conflict serializable or not. If it is so, then you need to find the equivalent serial schedule also. So you need to find if it is serializable, then you have to find the serial schedule also. For that, we need to have the precedence graph. So here, this is schedule S1 and this is schedule S2. And here we have to find out the conflicts, various conflicts in S1 and S2. So here this is the conflict in S1 and this is the conflict in S2. Now we have to create the precedence graph of these two schedules. So this is the graph of this one and this is the graph of second S2. Okay. So there is no conflict, right? So we can say S1 and S2 is, is a, sorry, there is no cycle. So here S1 and S2 is a conflict serializable. So here, therefore, we can say we have to create the serial schedule. Okay, serial schedule, right? Equivalent serial schedule. How you can find out for this? First, you have to remove the node, take the node which is having the least integrity. So in this case, T2 is the node. Okay, first T2, then T1. That will be the order. Serializing order of S1 and S2 will be T2 and T2. Okay. So this is all about the all the conflict serialization going on. Thank you.